So having given an overview of the data set, let's get started with it. The first thing we're gonna do is tell you how to read an R data file. If you downloaded the data set from the code repository, and that's vet underscore data dash one, um, and what you can do to load it is to use the load function. And once you download the dataset first, so if you download it, you should see how you have it named. Um, in my case, I have vet underscore data dot r data. So this is how I downloaded it, and I'm gonna use a load function on that, and that should actually load the vet.data file with the modifications that we already did in it. Looking at the structure of vet.data, we can see that the variables are coded actually correctly, and that's where we're gonna start. Um, One of the first issues that we run into when we want to do logistic regression is actually the imputation of missing values. Remember that when we have a logistic regression model, all observations that are missing just get ignored. And that is problematic, especially if you have many observations with missing values. So you have observations here on the demographic median income that we created. We changed the values that were zeros to be missing, and we have information here, observations about the gift average with missing values. In fact, there's a lot of variables in this particular data set with missing values, and it would be um, important to impute them before doing any logistic regression. So one thing we want to do is use the summary function to just get a read of how many of the variables have missing values. We created a data summary function in R that you can find in the code repository of in Canvas, and that is this file. You should have it on your working directory if you downloaded that. If you don't, you can download it one more time and use it. To load that function, we can use um, the source function, and you should put the name of the file. That is data underscore summary dot r. Let me see how I have it named on. So we have it named data space summary. So let me just copy and paste it. So that's the source function of that, and that should load the function into your global environment, and the function name is data.summary. So note that when you do source or you do the load functions, what you load doesn't have to be named exactly as the file. So here we had vet underscore data, but the R file that was loaded was vet.data. In the source function, we have data space summary, and we loaded data.summary as the function inside this file. All right, so let's first of all use the data.summary for the vet data file, and let's take a look at the missing values and the information that we have. All right, so we said that we are not going to use the target D variable, so we can ignore missing values in this one. But we have the gift average card with 1,700 observations missing. We have the demographic median home value, or the demographic age with 2,407 missing values, and then the median income having 2,357 missing values. We have to make imputations for those variables because they could, we would be looking at a lot of observations not being used because you don't have information in them. So let's start doing that. The first thing there uh, we have what we have looked at in the past is just using imputation on them directly, but there's something that I want to point out that you can do, and that is creating missing values indicators. So what is a missing value indicator? Well, that is another variable that you can create when you do imputation. So one of the things that can happen, or that happens when you do imputation, is that any observation that has a missing value, let's say age, you're going to impute it with either the mean, the median, whatever um, a measure of central location you want to put in there. But then once that variable is imputed, it's going to be filled out with some values in there. So you're going to lose track of when somebody did not report their age. But what happens if you, for some reason, think that if somebody did not report their income, has a missing value in income, has a higher or lower likelihood to respond to this donations campaign? Let me explain it another way. If somebody doesn't report their income, just puts a zero in there, and that's what we did when we changed zeros to missing. Is that person more or less likely to donate? We don't know if we just impute the variable and do not do anything with it. But we can create another variable, a missing value indicator, that is equal to 1 if that person did not report their income, and 0 otherwise. And that variable can become predictive. Can have predictive power. So this is what we're going to do. So the steps on doing this is create. So the steps are, number 1 is just to create that missing value indicator first. And then the step number 2 is after you create it, after you create the missing value indicator, then you can impute the variable. So let's start with step number 1. So let's do vet.data and create this missing value indicator. We're going to put an M on the first letter, and again, this is a variable name, so you can name it whatever you feel appropriate. But to be consistent in what I do, I'm just going to put an M underscore, meaning that this is a missing value indicator. And we're going to start with this variable. Let's create a missing value indicator for this one. So I'm going to put an M underscore to mean that this is a missing value indicator. And the next thing that I want to do is I want to create an if-else statement. So that would be if-else. And I want to say if this is missing, then this new variable is going to be equal to 1, and if it is not missing, it is going to be equal to 0. So the code for missing is just getting if it is a missing value is the is.na function. So I can put is.na of this variable, that data.income, and then basically this is gonna check if this variable has a missing value or not. If it is missing, then I want it to be as a 1. If it is not missing, I want it to be a 0. So that's what the if-else on that condition gives me, a 1 or 0. The next thing we want to do is put it as a factor. You can do this step separately, or you can put the as factor right here as well. So you can do as factor of this, so that we don't have to do that step afterwards. So basically this is created. It created a new variable called M underscore demographic median income, and basically it will have a 1 if it is if it is that median income is missing, or 0 if it is not. So let's take a look at the data summary one more time, and we're gonna find that we created that new variable, and you can find it here. Demographic median income having two levels, of course, is 1 or 0. We already changed it to be a factor, so that's why it appears here. We can take a look at a table on that. So we can do table of vet data underscore median demographic median income, and get rid of this. And you can see that we have 7,329 zeros and 2,357 ones, which is exactly this. It's gonna be a 1 when it is missing, so that's basically what we did. Again, this is called missing value indicators, and those are new variables that we create in order to make sure that we have information when that person or that donor did not we have a missing value for that, so that the donor did not input any information on that. Okay, so step number 2 is like we said, now we can do the imputation on the variable. And you remember that we have some ways to do that, and that can be using just using the isNA function. So let me give you an idea. But before that, let me just say something about the what should we impute it with. We have been doing mean imputation a lot, but one thing you have to know is that mean imputation is not necessarily the best option in most of the cases. So let me give you an example. If you take a look at a histogram of this variable, vet data demographic median income, which is the variable of interest. So let me just write it here. You'll note that this is skewed to the right. I mean, we can put a couple more breaks in there so that you can visualize it better. So whenever you have that skewness, you know that the mean and the median are going to differ, and a measure of central location is probably a lot better when we select the median as opposed to the mean, because the mean is going to go and try to chase those points up here. So the mean is going to be larger for skewed to the right data set. So a median imputation might be the best way to go with a data set that looks skewed. So let's do, in this case, let's do a median imputation of the variable demographic median income. Okay. So to do that, let's just overwrite the variable and say vet data $ demographic median income. And now we want to basically subset it to be the missing values. So every time these values are missing, then we are going to substitute that with the median. So this is the median function of this variable. And remember that we have to do NARM is equal to true whenever we do any imputation. So again, what the code does is take a look at this variable, and whenever you've subset it to be whenever it is missing, then you're going to change those missing values with this, which is the median. So once we do that, then we're not going to have any missing values. So that's the reason why you have to do the first step, which is creating this one first. Okay, so let's do that. And let's take a look at this summary one more time. Now you see that we don't have any missing values, but we have that missing value indicator, which might be predictive. Again, what we're saying here is what we can check if this variable, if somebody, if a donor did not actually give any information about his or her income, then now we have that flag there to give us any information and maybe know if that is a predictive variable.